Hello everyone, this is Lawrence again, and hello sir, have a nice day. Now, welcome of representing data through Graphical. Here is our first data. Here it is. So in 2016, three Asian countries are listed as one of the top mine nickel productions in the world. The data is presented here, compared to volume of production in the three countries. In the first data, we're going to compare the two volume of production in one of the Asian countries, namely Indonesia, Philippines, and China. The bar graph or column graph is appropriate to compare data. So all we have to do is to plug in the spreadsheet. So here it is. I already plugged in the spreadsheet. Then I use the bar graph because it is the appropriate in comparing data. Now I will show you how this bar graph became like this. Since we already plug in data, here is so we proceed to the insert. But first, we're going to highlight the cells first. All right, we'll go to the insert, go to the bar, and then so it's something like this. We'll put it here. Now, as you see, it's different from here. So all we have to do is to, by the way, this one is our chart elements. If you want to add, remove, or change chart elements such as the title, legend, grid lines, and data levels. And this one is our chart styles. You can set the style on color scheme for your chart. And this one is our chart filters. You can edit what data points and names are visible on your chart. So if you want to do like this, just click the chart title here, and you can select, you go to the home, you can select what you want, and you can fill the color like this, color pink, and you can also color your text here. So here you can, if you want to add the access title, just click the this one, chart elements, and you can check on the access title. So as you see, there's already an access title here. And after that, you can edit your access title. And you can go to home, just choose what font you want. You can fill the color, and you can color your text also here. Same. All right, as you see here, there is no numbers here, only the Asian countries I put. So if you want to do like this, just click the numbers here and press the backspace. Then it goes nothing here. So we're going to remove this one here, so a space from the Asian country here. So what I did here, I go into insert and go to the insert box, and then okay, let's try it. For example, Philippines. Philippines. Here's the Philippines, and adjust the size here. And then after that, we're going to turn it like this. And then move it from here. So it's the same like here. So if you want to adjust the size, the font size, so you can adjust on here. You can fill the color. And then this one, if you want to put some data level, just go in the chart elements and then check on the data level. So here it is. So you can, if you want to edit the color here, just press on it and then go to the home, and then you can fill the color whatever you want. That's, for example, it's color pink. It's pink. Now if you want to clear the grid line here, because here it's clear, so you can go in the grid lines and then press the arrow here, and then you go to the more options and then click the solid line. Now it's clear already. So now I'm gonna erase this one. Is it clear for you now? I will erase because we already have the final graph. And this one, our final graph. So now I will show you how this graph became like this. So it's already. Now as we see, if we compare this, it's very clear now that the Philippines get the highest volume in tons mine nickel production in year 2016. And the Indonesia got the second placer in the highest volume in tons mine nickel production in 2016, and the lowest volume in tons mine nickel production in 2016 goes to the country of China. So now we're done with our first data. Now let's proceed to our second data. So here we go, our second data. Suppose the data table represents the percentage composition of air pollutants in the atmosphere in last 5 years. Compare the contribution of each pollutant in the atmosphere. So we are required to compare the percentage composition. A pie graph would be the most appropriate to use menu 3. So now I will show you the procedure of to do a pie graph like this. All right, this one. As I told you earlier, if you want to edit this one, the chart title, you can press on it. If you do something like this, and then if you want to put the data level, just go in the chart elements and then check on the data levels here. So it goes like this. And then if you want to edit here, you wanted to put some color in it, just go to the fill color. For example, you want to put it pink, and then something like this. It's okay. If you want to change also the color like this here. For example, you want to color this, let's see, green. Not all. It's only one. Okay, just press 2. So that it's just only one here. You can fill the color, for example, green. Now it's green already. And now this one, I'm just showing the insert box here. Go to insert and text box. And then press in here. And then type, let's say, lead. And then BB. No, BB. Oh, wait. Leave and close parentheses. So here, so you can adjust also the color because it's just only too dark. You can adjust. For example, we can put yellow here. So we'll put here in the 11%. All right. The same procedure, just go to the insert max and do something like this. And this one, to make it big, okay, let's drag on it here. And then drag it here. Okay, now. And this will be our final pie graph. So let's erase this one here. Let's go to the cut. All right. This will be our final pie graph. So as we see, it is clear and easy to identify, and we can compare them clearly. Based from our pie graph, the air pollutants that has the highest percent contribution goes to carbon monoxide, which contains 32%. The second goes to nitrogen oxide, or NO, has a 25% contribution. Next, our third goes to sulfur dioxide, or SO2, contains 19%. The fourth one goes to particulate matter, which contains 13%, and the lowest percent contribution of air pollutants in the atmosphere, with 11% only goes to lead or PB. Next, let's proceed to our third data. So our third data is oxygen helps to break down the nutrients in the water. The amount of dissolved oxygen declines as waste is entered into a body of water. Suppose in 2015, a random sample of 8 Philippine lakes were tested to determine its dissolved oxygen or DO content, which is measured in milligrams per liter or mg per liter. After 5 years, the same lakes were tested with the same water parameter. Construct a graphic representations to show the comparisons of the variability of the two datasets. Since we are only required to represent a bar graph, line graph, and bar graph, so I decided to do a bar graph with a box. I don't know if there is something like this graph, but for me, the reason I created this because it's my way I could compare the variability of the given datasets. So the graph shows the comparison here. So let's do some examples. So what I did, because I do something like this, because if I will do like this table here, if I will insert, like for example, we'll highlight cells here and then insert and go to the column, it doesn't separate, it's together. So what I did, I encoded like this one. I put a 000 in the middle so that I will have a space here. So it goes like this. And then to have a box here, because this is a bar graph, I compute first Excel function of our 2015. This will be the mean. This will be the max. This will be the percentile and the Q1. Or I use also the formula of quartile, the same. And this will be the Q2. I use the formula, the percentile like this. And then also the same result, the quartile, the same. And this will be the Q3. I use the percentile formula. And this one, I use the quartile, the same procedure. And then I compute also the mean of 2020, the max, the Q1, the Q2, and the Q3. So after that, I draw it here in the box here. As you see, you think that I'm just putting it here something like this, but actually I measured it. I put, okay, let's see, the grid lines here. All right. After that, check on it all, and then go to the more options, and then solid line. Now it's clear. Another solid, make it solid line. Another, make it solid line. Now you see. I make the grid line visible so that I could measure it exactly, the Q1, Q2, Q3, the min and max. So our mean is 4.8, as you see here, this one. So this line, I'm just go in the insert, and then go to the shape, and this one, the line, just to here. And then you can change also the color here. So do like the line, and then I change the color, something like this. And then this box, Wait, let's erase this one first. The box, I go to the insert and then go to the shape, and then I choose the box like this, and then I adjust the size, and then I fill the color like this. Okay, like this. So I put in here, and then it goes like this. All right. Then after that, when I measured it exactly, then I go to the chart elements, then I erase the grid lines so that it's so clear. Now this is the final. So as you see, this one this is the 2020 samples from 1 until 8, and this one is the 2015 samples from 1 until 8, and here is the dissolved oxygen in milligrams per liter. So this one is our variability curve. So in this graph shows the comparison of distribution or variability of DA content across the 8 randomly selected lakes in the Philippines. The 2015 data graph shows a wider variability of DA content as shown by the distance between the maximum and minimum values 6.7 and 4.4 respectively. Also, the box's longer body, which represents the variability of the middle 50%. So for the 2020, this one here, it can be seen that there is lesser variability compared to 2015 data. This can be shown by the short range of the graph and the shorter body of the box. So the middle 50% of the data is approximately symmetric as the middle line. The middle value equally divides the box into two parts. So the result is very clear. The 2020 is the lesser, and the 2015 has the longer body. So this is the median. The 2015 has more variability compared to the 2020. So let's proceed to our fourth data. So for data is the table shows measurements of trunk and canopy circumference of nine randomly selected paragraphs in a 10 meters by 10 meters quadrant along the transect line. Show the graphical correlation of trunk and canopy circumference. Scatter plot is the most appropriate graph to show how the two variables correlate to one another, but scatter plot is not required. Thus, I will use a line graph to show how the trunk and canopy circumference correlated to one another. As you see, I already encoded the data in Excel and also the line graph, but I will show you the actual graphing since the data was plugged in already in Excel. Take note, don't include the sample number. Now let's highlight all the cells containing the numerical values of the measurement. So this one here, let's highlight on it. And then we'll go to the insert, and then go to the line. Okay, this. So over here. Wait. Okay, as you see, if you wanna edit the chart title, just press on it, and then you can go to the home and then change the font. You can fill color, you can change the color, and then you can add the label here Just go in the chart elements and then data levels. So it's already have. It's up to you if you want to change the color here. Just press on it. If you want to fill the color, and you can also add the access titles here, like this in my graph. Here, just press on it. And then you can also change the font here if you want to make it clear. Just go to the home and then Arial Black if you want. Jason. So it's depend up to you if you want to make your line graph clear. So this will be the our final graph. So I'm going to erase this one. And cut. Okay. So as you see, this line graph is very clear. So based on this line graph, it is clearly represented that the trunk and canopy circumference are correlated to one another. So now let us proceed to our fifth given data as our last graphing presentations. So the Philippine population is ever increasing, leading to more demands for food, space, and resources. The data are the population over 10 years from 1960 to 2020. To graphically represent the data and visually show the trend, construct a time series graph based on the given data. Highlight the cells containing the data values, including the header. So now you can highlight it first here. And you can go to the insert and go to the line. If you want to do like this, you can do. Then you can edit your chart title, what you want. If you go to home and then change the font, you can fill the color, you can change the color, and you can add some access title. Just click on the access title, data labels. It's like this. And this population, you can go in the insert and then go in the text box and you can type the population here. Okay, population. Wait. Okay. And then you can put it here. All right. Just remove the access title if you don't like. If you want to remove this, just click the backspace. And then something like this. And this will be our final. So I will remove this first. To make it here. Let's got this one. Also this one. Go to home. All right. But this will be our final line graph here. So it's a very clear, right? So now we can say that this line graph shown, it's clearly represent the data and visually show the trends where data points are drawn at regular intervals and the points are joined and connected by a straight line. So now we're all done. Thank you so much for watching this video. Before I end up this video, I would like to say thanks to my very humble and clever instructor, Sir a million of gratitudes for challenging us to use MS Excel computation in graphical presentation. It's another lesson learned that I could keep it for the rest of my life. And also, I would like to encourage everyone, those who don't have laptop, who doesn't know how to use MS Excel, please, don't be disappointed. If you have passion to learn, you will probably learn. There are many ways and choices of how to learn this. It depends up to you of how you would do it. Once again, have a nice day, everyone. Thank you. Bye bye.